Yeah.
So science time, guys. Science time. Let's write it down. Science time.
With Mr. Khan.
This is just science. This is the first one, so we'll just name it science. But today we're talking about forces. So please write forces in your notes. The objective, well now I don't have it pulled up anymore, but the objective was something like describe forces and their effects. So something like that. Describe forces and their effects. So let's write down our objective. Oops, I dropped my pen. Describe forces and their effects. Describe forces and their effects. Effects or affects?
Effects.
Effects. Generally, effect is a noun, affect is a verb. There are differences. You can use effect as a verb, but it means a completely different thing, so be careful. But describe forces and their effects. You will have an assignment. I'm going to erase the one that's already up here because this is from the last module. You will have an assignment. It'll be due on Tuesday. But we're talking about forces today, so let's get started on that. Yes.
Can we start this off?
Give me an example of one specific force you can think of. Yeah, Fate, let's hear it.
Newton's laws of motion.
Okay, those describe forces in general, and they're always true for every force. But what's a specific example of one force, Gunnar?
Hitting someone in the head with a bat.
Hitting someone in the head with a bat.
Bat.
What, Kesslin? What's another example?
I was just gonna say, throwing.
Throw. A throw is a force is applied to something that has been thrown.
Pushing.
Okay.
Why can't you push? Yeah.
Gabriel, are you gonna write any of this down here?
Motion.
It's kind of the same thing
Well-
as what we're saying.
We're going to talk about motion in a little while. Motion itself is not a force, but what do these things have in common? Can we think of a general definition that applies to all forces from these? If you have to think about other examples, that's fine. But we're looking now for a definition.
It
Contact.
moves gravity.
Okay, well, be careful with that. Because are there any kind of forces that don't have to be touching an object?
Yes.
Yeah.
Like what? Give me an example.
Wind.
Lightning.
Wind.
Wind is actually touching. It's air molecules, but it is touching. Magnets?
Yeah.
Well, that's a force, so magnets apply force. But do they have to touch to apply force to each other?
No.
No, so
They
forces
just
don't have to
they
touch.
Be near to each other.
But what do they cause? Forces. Forces.
Forces cause something to move.
Okay, not always that either. Not always that either, but I'm glad you brought that up. We'll come back to that.
To act upon something else. I don't know.
Am I putting a force on this whiteboard right now?
Yes.
Is it moving?
No.
No.
It could be.
Is it? It's not. It's not moving. So do forces always cause things to move? No. What do all these have in common though? They're all what?
They're
Forces are. We can agree they act on an object, right? That act on an object. What should I put in this blank? They're a what that acts on an object?
Sure. Something bullies do.
Always?
Bullies.
What do they always do? Forces always what or what on an object?
Act upon.
Forces are blanks. We're going to have these be plural. Or blanks that act on an object. Think about what the... Okay, what'd you say?
Said push or pull.
Yeah, perfect. Pushes or pulls. Pushes or pulls that act on an object. If you hit someone in the head with a bat, please don't do that. This is not recommended. Don't try this at home. But if you hit someone in the head with a bat, is that a push or a pull on an object?
That's a push.
Yeah, well, yeah. I'm not asking you, is it a push or a pull? But is it a push or a pull?
Yes.
Yes, it is. If you throw an object, is that a push or a pull?
Yes. Push.
If you push an object, is that a push or a pull?
It's a push.
And do magnets push or pull on objects?
Yes.
Yes.
There are other
It
examples.
depends.
This goes
because
on.
If it's like the negative on the...
Et cetera. Et cetera means and all the rest in Latin. Et cetera. So there are lots of examples, but they all have this in common. Forces are pushes or pulls that act on an object, okay?
Can you like unpause that? I don't want to look at
We can measure forces. Forces are measured. Oops, let's spell it right though. Measured in newtons, which is abbreviated in, capital N. And that's in the SI. Did we talk a little bit about the SI?
No.
Oh, Actually, we didn't. It was what was sometimes called the metric system. We call it the SI. Remember we talked how it stands for Système International. Now that I think about it, I might not have told you guys this, but it was part. It was to have been part of your scientific method discussion. But forces are measured in newtons. This is the unit we use. So when I say measured in, what do we measure distances in science?
Length.
Yeah, but what units do we use?
Feet.
Not in science.
Kilometers.
Centimeters, meters, and kilometers, right? In the same way we measure forces. In the same way we measure forces in this unit, newtons. Okay.
Forces newtons.
Forces are measured in newtons. As a side note, in the English system that we're used to, forces are measured in pounds. So when your weight is measured, weight is a force. Weight is a measure of the force of gravity acting on you, and so that force is measured in pounds. In the SI, that would be measured in newtons. An example that your book gives is a little seesaw, and the seesaw has some friends writing on it.
I love that. That's actually really good.
How are you so good at
So it has some friends writing on it, and in one picture. So first of all, if they're just balanced like this, what forces are acting on our friends?
feet?
Weight.
Yeah,
Gravity.
the weight, the force of gravity. The force of gravity is weight. Their force F sub g, the force of gravity acting on them, is pulling them down. If they're being pulled down, why don't they move?
Because it's going
They're
up and
balanced.
down. It's not like
Oh yeah, heck yeah, the forces are balanced. So what's pushing up on this guy? The force of what?
the force of the other guy.
Yeah, the what we call the normal force. The force of the seesaw pushing up on him is called the normal force. The normal force. This is happening right now too. If you think about me just standing here, if I'm standing still, are there forces acting on me?
Yes.
Yeah, what's definitely acting on me?
Gravity.
Gravity. The gravity is pulling down on me, but the floor is pushing up on me, keeping me in one spot.
Wow.
And when forces are acting like this, we call them balanced. Balanced forces.
Balanced forces.
Balanced forces. Same
This
thing.
guy looks like
Same
the
thing
guy
with
who came
the
in.
whiteboard. If I push on the whiteboard, what else is happening?
It's going.
The
It's like.
wall is holding it up, but you're
Yeah,
trying
the
to
wall
push
is
it
the
down.
wall is pushing back. So I'm pushing this way. The wall is pushing back, and so there's no movement. There's balanced forces only. The book has a section titled "Effects." Do you have a question, Chloe?
Are we ever
Talking to
gonna?
myself, sorry.
Effects of forces. The effects of forces. So what is the effect of balanced forces? We just said in the example of these
Balance.
people on a seesaw or me on the floor, what is the effect of that?
Gravity.
What does it cause? What?
Causes pressure.
Okay, yeah, there is pressure. Yes, what?
It causes like, yeah.
Think about, someone said something about motion. Someone gave motion as an example for us. That wasn't right. It was Gabe. But think about what the motion is. If there's only balanced forces, what's the motion like? Still, yeah. So let's put this. No change. No, not necessarily. No change in motion. No change in motion. It still could be moving, but the motion isn't changing. If there are only balanced forces, there's no change in motion. You get the difference? This does not mean there's no motion necessarily. It means that the motion isn't changing. So if I have only balanced forces acting on me and I'm already standing still, what do I keep doing?
Moving your hands.
You're breathing.
No, if I'm
Standing still.
Yeah, I keep standing still. If there are only balanced forces acting on me, and I'm already standing still, then I keep standing still. What if I'm already moving and the only balanced forces are acting on me?
You're already moving.
You're gonna stay
Then
moving.
stay moving, yeah. They stay moving. Okay, so then, if there's such a thing as balanced forces, what does that imply there also might be? Unbalanced. Unbalanced forces. And if balanced forces caused no change in motion, what do unbalanced forces cause?
Change in motion.
There you go. Change in motion. We have a fancy science word for this entire thing. Change in motion is called, does anyone know?
Wait, can I
Grammar.
take a guess?
Take a guess, sure. I'd be very impressed if any of you 8th graders knew this.
Gravity.
No, not necessarily.
What is it?
Physics.
Very broadly, it's part of physics. One more guess and then we're done.
Statistics.
No, I'm going to tell you. Acceleration.
Acceleration.
Called it.
You got it,
No,
Gunnar.
you didn't.
You know you did.
I was just questioning myself.
anymore.
So, balanced forces cause no change in motion. Unbalanced forces cause a change in motion, and a change in motion is called acceleration. Please write this
Why
down.
can't I do it?
These are all definitions. Once again, what's the definition of a force?
Forces are.
Forces
Pushes
are-
or
pulls. Pushes or pulls.
Pushes or pull. What are forces measured in?
Newtons.
Newtons. Newtons. Forces can be either balanced or unbalanced.
Yes.
If they're balanced, they do not cause a change in motion, and if they're unbalanced, they do cause a change in motion. And what's a change in motion called?
Acceleration.
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 Boom.
Have you ever heard the word acceleration used in your life? What do you
Yes.
usually?
I
If you
car
hear,
accelerates.
yeah, and what does that mean? When a car accelerates, we usually specifically mean that it's doing what?
Speed up.
Speeding up. Speeding up. But in physics, let's write this down. This is out of the room of the thing, I think, but I guess let's see if we do it over here. I'm sorry, Chloe. I mean, Kindle. Ways an object can accelerate. There are 3 ways an object can accelerate. 1, 2, 3. If you're on your CB radio and you hear the rancher or the trucker say, "Oh, I'm accelerating down Highway 20," what do they mean?
They're going
quicker.
They're going faster, is what they probably mean. In fact, if they were going slower, they'd probably use a different word. What would they say?
Decelerating.
Decelerating. Yeah, but that's not a word in physics. In physics, accelerate covers all 3 of these things. 1, an increase in speed. And we'll talk about speed in a second. 2, a decrease in speed. What's true of both of these things? They're both doing what?
Forces. They're
Yeah,
forces.
they're both an unbalanced force must be causing them, and they're both a change in motion.
Change in motion.
What's another way that motion can change?
It can change by something like
Force.
Yes,
A
that
rubber
causes
stop.
it.
An external
Yes, that's
force.
still a decrease in speed.
An external force.
That's what causes it. But I'm looking for one other way
Being
that an object could
regular.
change.
staying
Well,
one speed.
Careful, Gunner, because then would it be changing motion if it stays in one speed?
No,
Well,
it'd
you
be
should-
no change in
No
motion.
change in motion, so that's not going to work.
Starting
Think out of the box a little bit. If motion could change by changing speed,
crashing.
or increasing speed, or decreasing speed, that's still a decrease in speed.
Friction.
Still a decrease in speed. How else could it change?
Stopping.
Stays the same.
No,
Still
stopping. No
decreasing.
change in motion.
It's still
Okay, imagine this. Imagine you're going around the track, okay?
Going the exact same
I
speed.
already said that.
Yeah, that's still no change in motion. But listen, imagine you're going around the track, you're running around the track, and you're neither increasing in speed nor decreasing in speed, but your motion is changing. What else could be
Staying one
happening?
speed.
Staying one speed, but doing what specifically?
Turning.
Turning, there you go, changing direction.
Oh
Sorry
my
about that.
God.
Changing direction. Changing direction, which we also call turning.
I said, I'm just kidding.
We could rephrase any of these. We could say speeding up, slowing down, and turning. That would be fine too. But I've chosen to write them this way because it sounds more professional.
That person knows.
So those are ways an object can accelerate. Here are the ways an object ain't accelerating.
Decelerate.
No. We're not going to use that word.
not accelerate.
Accelerating.
What are the 2 ways an object can be if it's not changing its motion?
What did that say?
Going one speed.
Okay, yeah,
Object is not
constant
accelerating.
constant speed, and what else?
Not turning.
And straight line. Yep, not turning. That's one way.
Stopping.
Yep, and then not stopping, but
Slow.
Abrupt stop.
no, not slowing down. We're looking for something that is not
Freezing.
changing.
That is not changing.
Yeah.
Oh, just staying in one spot.
Yeah, still.
Constant speed and straight.
Yep, constant speed and straight line, or still. Every single object in the universe is doing one of these. If it's doing one of these 3, it must be doing what else?
Acceleration.
Accelerating. So what? Yeah, and what must be acting on it?
Force.
An unbalanced force. If any other object in the universe is doing one of these 2, what must be true of it?
It's not moving.
Not necessarily not
motion,
moving,
not
but no change in motion, and therefore only balanced forces or no forces acting on it.
What's that one word? Strength.
The constant speed. Constant speed. So if I roll a ball from here into the lab, what will eventually happen to it?
It'll
stop.
Yeah, it'll eventually slow down. So
Because
what?
it loses
Which
its
bounce?
force.
No, careful. Before you try to all answer it once, which of these 5 things is happening to that ball?
Number 2.
Decreasing.
Yeah, decreasing in speed. So what does that mean? It must be doing what?
Losing
Stop
down.
Yeah, it's slowing down. So that means that it must be doing what?
Getting rid
must
of
be
this.
accelerating. That means just change in motion. And that means it must have an unbalanced force acting on it.
It means it's decelerating.
Right? Do you follow? So, for any one of these situations, it's either accelerating or not accelerating, and that means we can tell either it has balanced forces or unbalanced forces acting on it. Doesn't even know what force is causing that ball to have unbalanced forces acting on it.
Second law.
You.
No, I'm afraid not. So the event, when I first started it, the roll gave it an unbalanced force, but as it's moving, am I still rolling it?
No.
No. What force is causing it to slow down?
Gravity.
Gravity.
No.
Friction.
Friction.
So let's add that to our list of examples here. Have you ever heard of friction?
Yes.
Yeah, I love
Yeah.
friction.
Let's define that real quick. Friction is a force,
Two forces acting upon each other.
not necessarily, a force
Acting
that,
upon another.
well, let's say, let's all agree on something. A force that does what?
Heat up.
Okay, it does cause heat. A force that,
Motion between
well,
objects.
Causes heat to slow down.
The slow motion between objects.
I like that, but let's use this word. A force that opposes motion. That means it goes in the opposite direction. Opposes motion, and I'm going to include Will's thing too because it's good. Generating heat. So it slows objects down. It opposes motion. I put opposes motion instead of slows objects down because if I push on the Promethean board, which I am really quite hard, I mean I'm leaning my weight against it. It's not moving though, and what force is stopping it from moving? Friction. But is it causing it not to move?
No.
Right. It's not slowing it down. It's preventing it from moving at all. It's still friction, but it doesn't only slow objects down. It opposes motion. Yes.
Wouldn't the kinetic energy be what creates heat and friction?
Kinetic energy turning into thermal energy. Yes. Is there anything I could do to make it so when I do push this, it does move?
Unlock the brake.
I could unlock the brakes, which would make the wheels be able to turn, and that changes it from
That
what
would
we call static friction to rolling friction. But could I change the surface? Yeah, I could use more
Get
force.
stronger.
I could use more force,
Yeah.
Good.
right? Which would allow me to counteract the friction better. Or what? Could I change anything about the floor? What can I do to the floor?
Put carpet on.
You could change the.
That would make it worse.
You
Put
could
something
make
under it to
something-
make it move
I
without.
could
Put oil on it.
Yeah, I could lubricate it, which would decrease friction, or I could change the surface altogether. I could make it ice, which has a lower what we call coefficient of friction, or anything like that. Okay. Oh, by the way, you should know that this little thing we drew here with an object. Let's draw another one. Give me an object real quick. Let's get a little more exciting than that. What'd you say?
Newton's cradle.
She was staring.
Level left.
Give you an
Yeah,
object.
just give me an
A
object.
banana.
Okay, banana's fine.
You hate bananas. I literally hate bananas. No, I just said
There
banana.
we go.
That's
Banana.
just the first word that came to mind.
That looks like an eggplant.
Banana. There's a banana. If we draw, listen. If we draw all the forces acting on the banana, then that's called a force diagram. Force diagram. We draw them from the center of what we call the center of mass of the banana, which is there-ish. And we draw, so what forces might be acting on this banana? Give me an example.
You. Peeling it.
Someone eating
No, well, just
Throwing it at a wall.
Dumping.
Grabbing it. Time.
What?
These are all wild examples. I'm going to put gravity, the force of gravity. And we'll
It does
pretend
change it.
F sub g, the force of gravity, force of gravity. And then we'll say it's resting on a table, so the other force is called the F sub in the normal force. You should remember that the normal force is the force that we call that pushes up on an object, keeping it from coming down. So look, here, there's a normal force acting on it. This is my book.
Drop it.
The force of gravity is acting on this, pulling it down.
But the
But what's
stand is-
keeping it balanced?
The stand.
The
The
stand.
normal, the normal force provided by the stand. What if I have the stand angled a little bit then? I'm going to make it, so angled a little bit.
The book will slide
The
down.
book's staying.
So the normal force is providing a little bit to counteract gravity, but what else is counteracting gravity here?
Friction.
Friction, exactly. That's why if I turn it a little bit more, eventually the friction can't take it
And
anymore
pour
and
it
slide
right
down. Let me make sure that I've got everything before. Does anyone have any questions while I look? No questions about this? This all makes total sense to you?
Actually,
Yeah, my
yeah.
question was, what'd you say about the banana?
Okay, Kesson has a question
What'd
right
you
now.
say about like the banana, like what you're doing to it, like the force or whatever?
This is called a force diagram, when we draw all the forces that are acting on it.
Oh, just draw all the forces.
Oh, one last thing before we're done. When we add up all the forces acting on an object, add up all forces, we call this the net force. Have you ever heard the word net used as an adjective like this before?
No.
You guys don't get paid because you're children, but when you have a job,
I get
when you have a job, you get something on your paycheck called the gross pay, which is how much money you made, and then the net pay, which is how much money you made minus taxes and Social Security and Medicare and all that stuff, okay? And so net is what we call it when we add up all the stuff that's positive and then we subtract all the stuff that's negative. That's called the net force. So if I look at this, if I have a box here, this is the classic example. If I have a box here and we have two of our homies pushing the box, and they're both pushing with 5 newtons of force, what's the net force?
10 newtons.
Yeah, it's 10 newtons, and we have to specify direction, but it's 10 newtons to the right. What if instead of that, I have, instead of 2 homies pushing 5 newtons to the right, I have one homie pushing 5 newtons left, please pay attention, and one homie pushing 5 newtons right. What's the net force now?
No, none.
0 newtons
Zero,
because
they're in opposite
they're
directions.
it's opposing forces.
0 newtons.
Goodness.
What if I have 5 newton homie over here, and then we got a big homie over here, and he's pushing with 500 newtons.
Oh, God.
What's the net force then? I should make this arrow longer. What's the,
The
net
net
force?
495 newtons.
You have to specify direction. 495 newtons
That's right.
right. So when we add up all the forces and then subtract the ones in the opposite direction, that's called the net force, okay?
But
What's the
Net
net
force.
what's the net force here acting on this homie?
Grab
No.
Homie jumping
Yeah,
up
there's
and down.
no net force, and if there's no net force then the forces are which one?
Equal.
Balance
Balance.
forces.
We can so balance forces also means no net force, and unbalanced forces mean I'll just put yes net force.
I have a question.
Yes, Will, let's hear it.
Does Newton at a certain point convert into something
Yeah,
like 1 inch is 1 inch?
1 newton is about 4.4 pounds. They're both forces, but a newton is also equal to the units a kilogram times a meter divided by second squared. We'll talk about that more when we talk about Newton's laws. But yeah, a newton is a force, and that can be converted to other force units like pounds. Other questions? Thank you, Will. Gabe.
So back to like the homies pushing the
Yeah, here's our homies.
Wouldn't you also have to take like the force of friction?
Yeah, we're in this universe. It's only these 2 dudes in this box. We're not thinking about any other forces, but sometimes we will consider those also. Other questions?
Nope. No. Not that I know.
What's a neutron?
A neutron is a subatomic particle. That's not anything to do with this. Well, not nothing to do with this, but it's not exactly.
That has to do more with like
Other questions?
Cells.
astronomy.
Oh.